Hello guys, so in this video we want to start looking at absolute value inequalities. We've already looked at absolute value equations where we said that the absolute value of x is equal to a means that the distance from x to 0 on the number line, right, is equal to a. Okay, so if I have the number line 0, 1, 2, 3, -1, -2, and so on. If I say absolute value of x is equal to 2, what that means is that this has two solutions. One is that x is equal to 2 or x is equal to -2, because the distance from 0 to 2 has 2 units, and the distance from -2 to 0 also has 2 units. Therefore, the absolute value of 2 is 2, and the absolute value of -2 is also 2. Okay, so those were absolute value equations. Question is, what does it mean to say that you have the absolute value of x is less than, so instead of equal to, is less than a? What does that mean? Let's take this example, x less than or equal to 2, right? What does that mean? This means that all values of x such that their distance to 0 must be less than 2 or equal to 2, right? So it means on our number line, all the points from, if you look at the positive side, every number, right, with a distance that is less than 2 will qualify. So 2 is fine because absolute value of 2 is equal to 2. They are equal, so that is fine. If I take 1.5, it will satisfy this because the absolute value of 1.5 is 1.5, and that is less than 2. So this is also true. So this is true. If I take 1, the absolute value of 1 is 1, is less than 2. If I take 0, the absolute value of 0 is 0, is less than 2. Do you see that? But if I take any number greater than 2, if I take 3, the absolute value of 3 is 3, but 3 is not less than 2. So we are starting from here, right? We start from here. See that if you put -1, the absolute value of -1 is 1, which is less than 2. So this is also true for this inequality. If you put in -2, the absolute value of -2 is 2, so it's equal to this. So this is also fine. But if you take anything beyond -2, for instance, -3, you're going to have the absolute value of -3, which is 3, but 3 is not less than 2. Okay, so anything beyond here is not qualified. So when you say the absolute value of x is less than or equal to 2, what that means is that all numbers that lie from -2 to 2 will satisfy this equation. How do we write that? So this, you can write this as x lies between greater than or equal to -2, but it's less than or equal to 2. Okay? So what that means is that whenever I see the absolute value of x to be less than a number a, where a is positive, of course, because the absolute value cannot be negative, this means that x lies between -a and a. Okay? This is very important for solving absolute value equations. So take note of that. So whenever you see absolute value of x less than some positive number a, this, you can also write it as this, as I explained here. It means that x must lie in this interval. Okay? Good. On the other hand, if you have the absolute value of x, let's go the other way. Instead of less than, we say greater than or equal to 2. What does that mean? Well, that means that if I put x in here, it has to be greater than 2. Well, 2 is okay, right? So you can start from 2. If you put 2, they are equal, so it satisfies. If I put 3, it also satisfies this because the absolute value of 3 is greater than 2, so this is true. Any number greater than 2, if you put it in here, will satisfy it. So all numbers that are greater than or equal to 2 will satisfy this equation. Well, what of numbers that are less than 2? If I put 1, the absolute value of 1 is 1, which is not greater than 2. So this does not satisfy, this doesn't. If I put negative 2, I have the absolute value of negative 2, which is 2. 2 is equal to 2. So that is fine. So you can start from here. If I put negative 3, absolute value of negative 3 is 3, which is greater than 2. So this is true. So from 2 all the way here, and from negative 2 all the way to negative infinity will satisfy this equation. Right? So x is greater than or equal to 2, or x must be less than or equal to negative 2. Okay? So this brings us to the very second, another important concept here, that if x is less than or equal doesn't matter. So if this was equal to, I just made this greater than or equal to, or less than equal to. All right? So if x is greater than a, again a has to be a positive quantity, then this means that x is greater than a, or x is less than negative a. Okay? So this is another important equation or inequality. So this is very important. These basic concepts. This is important, and that is also important for solving absolute value inequalities. Okay? So keep that in mind. Now, you can easily derive this as well, right? The absolute value, remember, we said the absolute value of x means that x here will be greater than a. This also means negative x is greater than a. Well, if I multiply through by negative or divide through by negative, I have to switch the sign. So this can also be written as x is less than negative a. You see that? So that is why we have x greater than a and x less than negative a. Okay? You can do the same thing here. Okay? Here this means that x is less than a and negative x is also less than a. But from here, if I multiply through by negative, it means I have to switch the sign here, right? This has to be greater than negative a. Okay? So x is greater than negative a and x is less than a. These two form that. All right? Okay. So this is an introduction to absolute value inequalities. So we're going to do one simple example of this, and then in the next video we'll do more extensive ones. Okay? So if you have for example, suppose you have the absolute value of 2x. The absolute value of 2x, okay, is less than 3. What is x? What is the set of values of x that will satisfy this? Well, you can just use the definition. There are actually 3 different ways by which you can solve it. Okay, I'm just going to use the first one, and then later on I will do some other ones showing different ways by which you can solve it. Because it's less than, okay, this means that what is in the absolute value symbol will be less than negative 3 and then 3. Remember, absolute value of x less than 3 means that x lies between negative a and a. Keep that in mind. So this can be written as this. We are looking for x, so you can divide through by 2. So divide by 2, by 2, by 2. Because 2 is positive, the signs of the inequalities remain the same. You don't have to switch them, right? So this cancels out, and so you get x lies between negative 3 on 2 and then 3 on 2. So this is the solution set. Okay, that satisfies this equation. You can also write this in another way, right? You can write this in another way. You can say it's from negative 3 over 2 to 3 over 2. Alright? Good. What if it was less than or equal to? Same approach, right? If it was less than or equal to, you are going to have 2x is less than or equal to 3, will mean that 2x lies between negative 3 and 3. Divide through by 2, you have negative 3 over 2 is less than or equal to x less than or equal to 3 over 2. And that gives you the solution set. Or this you can write as, this means it's equal to, so this is included, negative 3 over 2. There's equal sign as well. So 3 over 2. So this or that. Okay? Good. On the other hand, if this was not less than, but greater than, okay, so I'm going to get rid of this. Suppose we had x is greater than 3 or equal to, we're just going to do greater than 3. Then we use the same concept again. If the absolute value of x is greater than a, this means that x is greater than a or x is less than negative a. Okay, this is important. It means we are on the flanks. Okay, so you use these two inequalities to solve that. This means that 2x, right, is greater than 3 or 2x is less than negative 3. And then you solve them separately. This one, solving this, divide 2 by 2, this cancels. It means x is greater than 3 over 2, or divide 2 by 2, divide 2 by 2, x is less than negative 3 over 2. Okay, so that is your solution set. And this is how you can write it. Note that x is less than negative 3 over 2 means that from negative 3 to negative infinity. So you have negative infinity all the way to negative 3 over 2, right? Union of this, from this to infinity, right? From 3 over 2 all the way to infinity. So you can write it as this or you can write it as that. Okay? So even though these are simple equations, but they give you the concept, the main ingredients that you need to solve any complex absolute value inequality. So in the next video, I'm going to do a few more examples in the next couple of videos. All right.